Hello everybody, this is Mrs. Dehn-Brastad, and today we are going to continue Chapter 2, and we're going to learn about deductive reasoning. We're going to use deductive reasoning to verify conjectures. So we're going to start with a warm-up, and in our warm-up we're going to make sure that you understand, this is just from earlier this chapter, so it's not way back from Chapter 1, but identify the hypothesis and the conclusion of each. So when you do that, remember it's if the hypothesis, then the conclusion. So the hypothesis is the part after the if, and the conclusion is after the then. And it looks like I started to rewrite this and it didn't get erased. So a mapping that is reflection is a type of transformation. You want to rewrite that, and you can see I kind of started it so that it's if-then form. So like if the mapping, a mapping that is a reflection. So if you want to say if the mapping is a reflection, then it is a type of transformation, I think is how you'd say that one. The second one too is not in if-then form, so we need to rewrite it. But this one's a little easier to rewrite. You probably are just going to start with the beginning part and say, if you take the quotient of two negative numbers, or the quotient, if the quotient of two negative, no, let's see. If, I guess you'd write if you take the quotient of two negative numbers, then it will be positive or something like that. Let's see how they did theirs. Okay, so for the first one they said if a mapping is a reflection, then the mapping is a transformation. The second one, if two numbers are negative, oh, the quotient went with the conclusion. So the only part, this one is tricky, the only part that they started with is if you have two negative numbers. So if two numbers are negative, then the quotient is positive. That is a tricky one. And then the last one, if you got to it, is false, because it says if x is a number, then the absolute value of x is greater than 0. 0 is a number, and the absolute value of 0 is not greater than 0. It's greater than or equal to 0. So if they just would have had a line underneath here, it could have been true. Okay, our objective today is to apply the law of detachment and the law of syllogism in logical reasoning. Two different kinds of deductive reasoning we're going to work with. And that's the only vocabulary word is deductive reasoning. All right, this is a review from Chapter 2, Section 1. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true, like when we look for a pattern. Like, for example, it's rained every time the clouds get this dark, therefore it'll rain today since the clouds are dark. So it's when you're learning from experience. It's when you look at examples or patterns and you are trying to, figure out what's going to happen next based on what happened before. Deductive reasoning is when you use logic to draw conclusions from given facts, definitions, and properties. Those include logical thought, research, and scientific evidence. Usually if you're watching a TV show and there's a lawyer arguing, he's usually using deductive reasoning. For example, my client was in Kansas on the day of the robbery in New York, therefore he cannot be guilty. Or, my client is 4 foot 8 inches, and the witness claims the thief towered over her 4 foot 3 inch frame, therefore my client is innocent. So these are not looking at examples or patterns. They're trying to use logic or research or facts in order to argue your point. So let's decide if this is inductive or deductive reasoning. There is a myth that you can balance an egg on its end only on the spring equinox, which is like March 22nd or 21st or something like that. A person was able to balance an egg on its end on July 8th, September 21st, and December 19th. Therefore, this myth is false. So we're just supposed to say whether this conclusion, this argument, is inductive or deductive reasoning. Now remember, inductive is when you look for a pattern, when you look at previous examples, and then you use that to make a judgment, to see what would happen next. Deductive reasoning looks at facts and logic and things like that, not a pattern, not past examples. Now this is based on a pattern of observations. They did this 3 times in the past, those 3 dates. So that's a pattern of observations, so this would be an inductive reasoning. Okay, here's another myth. There's a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above the Earth. The moon is about 237,000 miles above the Earth. Therefore, the myth cannot be true. So in this example, we're using logic. It's logical reasoning based on scientific research. They're not using lots of examples of the past. They're not saying, well, we couldn't see it from the moon on this date, and we couldn't see it from the moon on this date. That's not what they're doing. They're saying it doesn't make sense because if you can see it just barely when you're this close, how could you possibly expect to see it when you go that much farther away? So that is deductive reasoning. Okay, here's one more myth. A myth that the eel skin wallet will demagnetize credit cards because the skin of the electric eels used to make the wallet holds an electric charge. However, eel skin products are not made from electric eels. Therefore, the myth cannot be true. This is just using facts and logic. It is an example of deductive reasoning. It's not looking at a pattern or past examples. It's just using logic. Okay, in deductive reasoning, if the given facts are true and you apply the correct logic, then the conclusion must be true. The law of detachment is one valid form of deductive reasoning. We're going to learn about 2 forms of deductive reasoning other than just, use your brain. There's 2 specific forms. Here's the law of detachment. The law of detachment says that if you have a true statement, let's say we write a conditional. If something, then something. I wasn't supposed to write something. I was supposed to write a line. So, if the first part of your statement, your hypothesis, is true, if this is true, and your statement is true, then this has to be true. Your conclusion has to be true. If you know that this is a true statement, what I just wrote, and the first part is true, then the second part has to be true. That's the law of detachment. Now, it doesn't work the other way around. You can't say that if this is a true statement and the conclusion is true, then the hypothesis is true. It doesn't work that way. The converse doesn't work. Only this conditional works. So let's look at an example of this. I'm going to do a different example. That one's a little harder. Let's say if it is snowing, then I build a snow. You can't build a snowman. Let's say then I shovel. Okay, so first of all, we have to see if this is a true statement. Is it true that if it's snowing, then I shovel? Unfortunately, yes, that's a true statement. So I'm starting with a true statement, a true conditional. Now I have to see if the hypothesis is true. Well, I'm looking out the window, it's not snowing. But let's pretend, let's fast forward a few months, and let's say it's snowing, okay? Let's say it's snowing. Deductive reasoning says that if this is a true statement, if it's snowing, then I shovel, and it is snowing, then the conclusion that you can make is, I will be shoveling. I shovel. Okay? So you can assume that the conclusion is true and it will happen. That's your conclusion. All right, let's look at this one. Here is your given. This is your statement. If you want to go on a field trip, I'm going to even write this as a then you must have a signed permission slip. Okay? So this is my hypothesis. You want to go on a field trip. The conclusion is you must have a signed permission slip. Then they tell us that Zola has a signed permission slip. And they're saying, is this conjecture valid? Does Zola want to go on a field trip? So again, it's supposed to be if P, then Q. If this is a true sentence, and we're going to assume that these are mostly true unless they tell you they're not, and if the first part is true, then you can assume the last part is true. All right, so let's see. If you want to go on a field trip, then you must have a signed permission slip. That makes sense. We're going to call that true. Are we told then that somebody wants to go on the field trip? No. We're told that Zola has a signed permission slip. This isn't the hypothesis, this is the conclusion, which isn't the way it's supposed to be. It's supposed to be the hypothesis is supposed to be the given. So this is not not valid by the law of detachment. It might be valid from some other method, but it is not valid by the law of detachment. Okay, let's look at another one. If the side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters, 5, 12, 13, then the area of the triangle is 30 centimeters squared. Okay, so that's what our given is. That's our if-then. So if that's true, and it is, then, or it is true if we have a right triangle anyway, then if they tell me that the side lengths of a triangle are 5, 12, and 13, then I could say that the conclusion is true. But instead, they tell me that the area of a triangle is 30 centimeters squared. If the area is 30 centimeters squared, I could have a different triangle. I could have a triangle that's 5 by 6. Oh no, that would be 30. I need it bigger. 10 by 6, there. And that's not the same then, is it? So this is not valid by the law of detachment because they gave me the wrong part again. They're giving me the conclusion being true instead of the hypothesis being true. This is just working through it step by step by step. They're going to say the same thing I just said. The conjecture is not valid because they gave you the conclusion rather than the hypothesis. All right, let's try this one. In the World Series, if a team wins 4 games, so here's the if-then. If a team wins 4 games, then the team wins the series. Now here's what they're telling us is true. The Red Sox won 4 games. Is that the hypothesis? If a team wins 4 games, yes. This time they're giving me the right thing. They're giving me something that matches the hypothesis. If a team wins 4 games and then the Red Sox won 4 games, that matches up. That means that we can assume the conclusion is true. So their conjecture of the Red Sox won the World Series matches my conclusion of the team wins the World Series. See that? So this time it is valid by the law of detachment because they gave me the right parts. They told me that the hypothesis is true, which means then that the conclusion will be true by the law of detachment. Okay, here's another one. If a student passes his classes, the student is eligible to play sports. Ramon passed his classes. The hypothesis of the statement matches the given information. So that means that we can assume that the conclusion is true. The student is eligible to play sports. Ramon is eligible to play sports. Valid. That is valid by the law of detachment. Okay, there's another one called the law of syllogism. We're only going to do 2. And this one, it's like 2 conditional statements are linked together. And if you have 2 conditional statements linked together, we can jump over the middle one and just assume the hypothesis of one implies the conclusion of the other. For example, I'm going to do a really simple one. I'm going to go back to my snowing thing. If it is snowing, I'll change it up a little bit, then my driveway fills up. fills with snow. Okay? If my driveway fills with snow, then I have to shovel. Well, or I can make my boys do it. Have to shovel. Now, see how the conclusion of the first one, here's a yellow color, my driveway fills with snow, matches the hypothesis of the second statement. My driveway fills with snow. They're the exact same thing. They don't have to be the exact word by word, but they have to mean the same thing. They have to be almost the exact same. So what I can do then, it's kind of cool, is I can just jump over the parts that are the same. And I can write a new sentence, a new statement that says this. My new sentence would be, I'll write it right here for lack of room. If it is snowing, now I'm going to jump over the whole part about my driveway, then I have to shovel. See how I jumped over the driveway part? But it's true, right? Because if it's snowing, then my driveway fills with snow. Yep, happens. If my driveway fills with snow, then I have to shovel. So I can just skip over the parts that are the same and write, if it is snowing, then I have to shovel. That's called the law of syllogism. Here it is in symbols. If P implies Q, or if P then Q, and if Q then R are true statements, then P implies R, or if P then R is a true statement. So it's letting us put the parts that are the same and basically skip over them and just go to P implies R, or if P then R. All right, let's do another example. Here's the thing about the law of syllogism. You can reorder your first two sentences if you want. So here we have no human is immortal. Fido the dog is not human. See how the first sentence starts with something about being human, and Fido the dog is not human? I'm going to reorder this. I'm going to write Fido first, that Fido sentence. Fido the dog is not human. And then the second one, I'm going to write the no human is immortal. Now, never mind right now how silly these are and can be. Now, is there a way to change Fido the dog is not human into an if-then sentence? Let's see. If, then he is not human. If Fido is a dog, I guess I could write. If Fido is, I'm going to change that a little bit, is a dog, then he is not human. Let's change it to that. He is not human. And let's change the second sentence to an if-then. If you are human, you are not immortal? No. No human is immortal. Yeah, I think that would work. If no human if you are human, then you're not immortal. Okay. So, does the conclusion of the first, he is not human, match the hypothesis of the second, if you are human? Not exactly, right? They're not exactly the same thing. One of them has a not and one of them doesn't. So it doesn't, the law of syllogism does not work here, because the hypothesis of the first does not match the conclusion of the second. Could I have left the two sentences in the other order? Would it work? Then I would have to say, if you are human, then you are not immortal. If Fido is a dog, he is not human. Those don't match either. So either way I write it, I'm not getting the conclusion of one matching the hypothesis of the next. They're not the exact same thing, then I can't use the law of syllogism. So it's not valid by the law of syllogism. Okay, let's look at this one. If a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. Notice how this time it's already if-then, so that makes it easier. If a figure is a kite is the hypothesis. The conclusion is, then it is a quadrilateral. Then the next one starts out with, if a figure is a quadrilateral. See how they match? It is a quadrilateral. Matches, a figure is a quadrilateral. Which means you can skip over that and go right to the conclusion. If a figure is a kite, then it is a polygon. And that's exactly what their conjecture is. If a figure is a kite, then it is a polygon. Now, they're going to break this up into pieces a little bit more. They're going to use the P, Q, and R. Now remember, using law of syllogism is if P, then Q. If Q, then R, means that you can skip over the Q's and write if P, then R. Okay. So the P is the figure is a kite, the Q is a figure is a quadrilateral, and the R is that it's a polygon. And this one followed exactly the right format, so it was valid by the law of syllogism, whether we use symbolism to do it like they did, or whether you use the words and match up the different parts like we did. Okay, here's another example. If a number is divisible by 2, then it is even. If a number is even, then it is an integer. See how we said the same thing twice? It is even. It is even. Number is even. So we could use the law of syllogism, and if we use the law of syllogism, we should be able to say that if a number is divisible by 2, then it is an integer. We'll skip all the other stuff. But they didn't write that. They didn't write if a number is divisible by 2, then it's an integer. They switched the order. They said if a number is an integer, then it's divisible by 2. They did it wrong. You can't change the order. You have to write it just if P, then R. You have to keep it in the same order. The way they wrote it, it doesn't work anymore. They've messed it up. So their conjecture is not valid by the law of syllogism. It doesn't even work anyway because any integer, I got to get a different color here. An integer like 7 is not divisible by 2. It's not true. And it doesn't matter. You don't have to find a counterexample or anything. You just have to say they didn't follow the rules. It's not valid by the law of syllogism. Oh, here they broke it all up again. So it's not valid. Here's one that you're supposed to try on your own. Now, in this case, it might help to rewrite our sentences. If an animal is a mammal, then it has hair. If an animal is a dog, then it is a mammal. Do you see how the conclusion of this one matches the hypothesis of this one? So we should reorder our sentences. This should be our first sentence, and this should be our second sentence. You can reorder the whole sentence. You can't change the order of different parts of one sentence, but you can put the sentences in different orders. So if an animal is a dog, then it's a mammal. And then the second sentence would be, if an animal is a mammal, then it has hair. So the law of syllogism says that we could skip over the part where the conclusion of one matches the hypothesis of the other one. So it is a mammal and an animal is a mammal. We can skip over that and go from if an animal is a dog, then it has hair. And that's exactly what they wrote for their conjecture. So then we would say, in yellow, we would say that yes, it is a valid conjecture because it does meet the law of syllogism. All right, so now we have applying the laws of deductive reasoning. Now this is where you would just have to figure out what conclusion could be made from this information. And sometimes we have to use the law of detachment, sometimes we have to use the law of syllogism, but we're just going to see if we can figure out what conclusion could we draw. So we're given several things. If 2y equals 4, then z equals -1. If x plus 3 equals 12, then 2y equals 4. So there's two statements that were given. Notice how this conclusion matches this hypothesis. If you ever see that happen, then we should reorder these sentences. This should be number 1 and this should be number 2, because maybe we can use the law of syllogism. So number 1 is if x plus 3 equals 12, then 2y equals 4. And the next one would be if 2y equals 4, then z equals negative 1. And we're also told that this is true. Is this the hypothesis of our first sentence? See how they match? That's the hypothesis, which means that then our conclusion is also true. So our conclusion should be that z equals negative 1. Now we're not even trying to solve these equations or anything. We're just trying to look at the different parts and the hypothesis and the conclusions and go from there. Okay, part B. If the sum of the measures of two angles is 180 degrees, then the angles are supplementary. If two angles are supplementary, then they are not angles of a triangle. So this time we don't have to reorder the sentences because this conclusion, the angles are supplementary, matches the hypothesis of the second one. The conclusions match. The conclusion matches the hypothesis, which means that we can jump over this using the law of syllogism and say that if the sum of the measures of two angles is 180, I have to get that in there too, then they are not angles of a triangle. Okay? Now we're also given some more information. We're given that measure of angle A is 135 and measure of angle B is 45. Is the sum of those two equal to 180? Does the hypothesis hold true? Yes, the hypothesis is true. So then our conclusion is they are not angles of a triangle. That's what we can conclude. Since the hypothesis was true, the conclusion will be true, using the law of syllogism. Okay, this one says, this is law of syllogism again, I bet. If a polygon is a triangle, then it has three sides. If a polygon has three sides, then it's not a quadrilateral. And then they also tell us that polygon P is a triangle. So because the conclusion of the first matches the hypothesis of the second, we can basically jump over it and say if a polygon is a triangle, then it is not a quadrilateral. Now we're also given that polygon P is a triangle, so that's the hypothesis. The hypothesis is true, so we can jump over and we've got the quadrilateral then.